Welcome to Mr. Robertson's experiment into how the surface area of a beaker affects how quickly water cools. To do this, I'm going to need a variety of different surface areas. So I have, helpfully, 3 beakers, helpfully labelled number 1, which is very small, number 2, which is in the middle, and number 3, which is massive. Right, first thing I will need to know is the surface area of any water that goes in these. Now, I've got to assume that it's going to be a cylinder that fills up this beaker. So, first thing I need to know is the radius of the beaker. Turn it over, so I've got the better end to measure from. 30 centimetre ruler tells me that is 50 millimetres in diameter, that's 5 centimetres. So for beaker 1, the radius is 2.5 centimetres. That's what I've got there. Okay, do the same thing for beaker 2. If you can hear that hissing sound yet, that's my kettle switching on. Right then. That beaker number 2 has a 60 millimetre diameter, so that's 6 centimetres. So the radius for beaker 2 is 3 centimetres. Nice and clear on there. Right, beaker number 3, same thing, invert it. Ruler on the top. That is 85 millimetres, so 8.5. Divide that by 2 to make it into the radius. That's going to be 4.25 centimetres. Right, that is the first piece of information that I needed to know. Right, what I will now be doing is switching this off so I can get a measuring cylinder. Armed with my trusty measuring cylinder here and my kettle of freshly boiled water, I will be able to measure 50 millimetres of water out of here into here and place it into one of these beakers. Once the water's gone from the kettle into the beaker, I will need to use my trusty thermometer to record how much temperature it loses, and I will also need to use my ruler to figure out the height of the water. Now this is vitally important. I've just said that we're going to need to assume it's a cylinder of water in here. Now, I can use my radius from here to work out the surface area. I'll then need to know the height of that cylinder so that I can work out the total surface area. It's easy peasy, just need those 2 bits of information. So, next step will be take boiling water from here, pop it into here, put it into there, and then measure the temperature after 2 minutes. Right, now, having passed the camera to my fantastically talented assistant, what I need to do is make sure my kettle is nicely freshly boiled. That's not staying on, so that must be exactly 100 degrees in there. I'm going to take 50 millilitres of water from here, pop it into my measuring cylinder to make sure it's exact, and then I'm going to transfer it into beaker number 1. As soon as I've done that, pop the thermometer in just to double check the starting temperature is still 100 degrees. Then I will wait for 2 minutes using my timer, which you'll be using a stop clock, I'm using my phone. After 2 minutes, I'll record the end temperature in my table here. Right, this table looks horrifically complicated at the minute. I'll explain that after we've got all the data into it. Thank you very much. Okay, so that's still at 100 degrees. Let's measure very carefully here, folks, because that is boiling water. 50 millilitres exactly. 50 millilitres into beaker number 1. Okay, we're just coming up towards 2 minutes now. Leave that bright so we can see it. As soon as this stopwatch reaches 2 minutes, we'll read the temperature from the thermometer and record it in our table. Okay, we're up to 1 minute 58, 59. 2 minutes, the temperature was 60 degrees exactly. Okay, take my thermometer out very carefully, pop it there, and I will record my end temperature, 60 degrees in here. Right, now, there's obviously, this is a very complicated table, it's very different to the last time we saw it. What I've done is I've kept our radius here, and I've put another column for the area here. What we'll be doing there, we'll be working out the area of just the bottom of the cylinder. Okay, after that we'll use the height of the cylinder of water to turn it into the total surface area. To do that, I need to come back across to my beaker, and I need to record the height. Now the height there is 34 millimetres, that's 3.4 centimetres. So I'll be recording 3.4 in there. Ready to, a little bit of maths in there. Our start temperature was 100 degrees C, the end temperature was 60, the change is 40 degrees. Okay, having completed the experiment, just go back through the equipment we used. We had a kettle to heat up the water. We needed a ruler in order to measure the surface areas, obviously a thermometer to measure the temperatures, measuring cylinder to ensure we had accurate volume measurements, and we needed the 3 beakers. Beaker 1 very short, small, beaker 2 medium sized, and beaker 3 quite large. Right, coming across the results table, beaker 1, 2, 3 here, then I recorded their radii, then I recorded their heights. Notice that I accidentally included a column in my table that I didn't need, because using this equation, area of a cylinder is 2 pi rh plus 2 pi r squared, I can directly work out the total surface area. So for beaker 1, with a radius of 2.5 centimetres, a height of 3.4 centimetres, the total surface area was 93 centimetres squared. For beaker 2 it's 90 centimetres squared, and for beaker 3 it's 138 centimetres squared. Now that seems quite interesting, because you would assume beaker 3 would have a larger surface area than beaker 2. However, it's not the surface area of the beaker we were talking about, it's the surface area of the cylinder of water inside. Using the surface areas, I can then compare that to my second table here, which compares the changes in temperatures. So all 3 started at 100 degrees centigrade, and then they dropped to these values. Notice, smallest surface area decreased the least, better shown by my column entitled change. Here we can see the change in temperature for the 3 beakers.